A very good morning to all of you. Here in this video, I am going to start a new topic of mathematics, that is arithmetic progression. But before I start, let me clear your one doubt, and that is, if you have made only one copy for mathematics, then I would request you to keep a proper note of the content given by both the teachers date wise in the same copy. And if you have the option to make two different copies, that is, if two copies are available with you, then it's better that in one copy you keep a note of the content and the notes given by Asit sir. In another copy you can keep a proper note of the notes given by me. But at this point of time you should be clear that after reopening from this lockdown, we teacher will not ask you to make any different copy for it. So both the options are open for you. Now here we should start with the topic. Consider the following arrangement of numbers. In each of the arrangement of numbers are arranged in a definite order according to some rule. In the first arrangement, the numbers are cubes of natural numbers. And in the second arrangement, the numbers are reciprocals of natural number. Whereas in the third arrangement, the numbers are even natural number. Each of the arrangement is a sequence. Thus, we may define a sequence first. And here is the definition. Some numbers arranged in a definite order according to a definite rule are said to form a sequence. The number occurring at the nth place of a sequence is called its nth term, denoted by Tn or An. It is also called general term of the sequence. So here at this point of time it should be clear that the various numbers occurring in a sequence are called its term. We denote the terms of a sequence by A1, A2, A3 and so on etc. or x1, x2, x3 and so on. Here the subscript denotes the position of the term. First term or the number at first place is called its first term of the sequence and is denoted by A1. The number at the second place is called second term and is denoted by A2 and so on. In general, the number at the nth place is called the nth term of the sequence and is denoted by An, as I have explained now. And also I have explained the nth term is also called the general term of the sequence. So here I am with one example. In this example, you can see 2, 4, 6, 8, 10 and so on is a sequence whose first term is 2, that is A1 is equal to 2. Second term is 4, that is A2 is equal to 4. In the same way, third term A3 is 6 and fourth term A4 is 8 and so on. Let us now discuss some example to illustrate the application of what we have discussed so far. Here in example 1, write the first three terms in each of the sequence defined by the following. So first we have An is equal to 3n plus 2. Putting n is equal to 1 2 and 3, we get the first term of the sequence a1 is equal to 3 into 1 plus 2, which gives us equal to 5. Second term of the sequence a2 is equal to 3 into 2 plus 2, which results as 8. Third term of the sequence is 3 into 3 plus 2, which gives us 11. Thus, the required first three terms of the sequence defined by an is equal to 3n plus 2 are 5, 8 and 11. In subtopic 2, we have the general term, that is nth term an is equal to n square plus 1. Putting n is equal to 1, 2 and 3 for first, second and third term of the sequence, we get for first term a1 is equal to 1 square plus 1, which is equal to 2. Second term a2 is equal to 2 square plus 1, which is equal to 5. And third term a3 is equal to 3 square plus 1, which gives 10. Thus, the first three terms of the sequence defined by an is equal to n square plus 1 are 2, 5 and 10. Now let us consider a bit different question. And here in this, what is the 18th term of the sequence defined by an is equal to n into n minus 3 divided by n plus 4. So we have here for the general term, that is nth term, an is equal to n into n minus 3 divided by n plus 4. And we want to find the 18th term. So we will have to consider n is equal to 18. And we get a18, that is 18th term is equal to 18 into 18 minus 3 whole divided by 18 plus 4, which results 18 into 15 divided by 22, which is equal to 135 by 11. Now, in the above discussion, we have seen that a sequence can be described by listing its first few terms till the rule for writing down the other terms become clear. We can also describe a sequence by writing the algebraic formula of its nth term or general term, as we have seen in the examples. But in some cases, the terms of the sequence do not follow some fixed pattern, but they are generated by some recursive relations. And for example, you consider for instance this given sequence. Thank you for today.